EET 114, Chapter 15, Series AC Circuits. This is a frequency response for Series AC Circuits, problem number 32 for the Series RLC Circuit. So this is the diagram right here. R is 1 kilo ohm. The inductance is 20 millihenries, and the capacitance is 8200 picofarads. So part A says plot Z sub t and theta sub t versus frequency for a frequency range of 0 to 20 kilohertz in increments of 1 kilohertz. So first you have to figure out what Z sub t magnitude is. And that's going to be the square root of R squared plus X sub L minus X sub C squared. And the phase angle will be the inverse tangent of X sub L minus X sub C divided by R. So if you plot those with, in these, it says increments of 1 kilohertz, but it went 1, 5, 10, 15, 20, so it didn't go exactly 1 kilohertz increments, but at 0 hertz, the impedance goes to infinity. Okay. So when F is equal to 0, X sub L ends up equaling 0, but X sub C goes to infinity. So when you take 0 minus infinity and square it, and then take the square root, it's going to be infinity. When you do the math of theta t, it ends up equaling 90 degrees, or minus 90. And then there's a point of inflection in the middle. It goes to 0, and then it goes almost to plus 90 here. As the frequency would increase, it would go closer and closer to plus 90. And likewise, you do the calculations. What you have to do is put in these two formulas. You substitute 2 pi f L into X sub L, and you substitute 1 divided by 2 pi f C in for X sub C, and you get these different values back. Then it says plot V sub C magnitude only versus frequency for the same frequency range of part A. So V sub C, using the voltage divider, is going to be X sub C times E divided by Z sub T. And again, for X sub C, plug in these values, and then ZT is going to be these three added together, which was this formula up here. And then when you plug in the frequencies, you get the V sub C out here, and you plot it. It looks like this. And then part C says plot I, the magnitude only, versus frequency for the same frequency range. So again, I is going to be E divided by ZT. And when you put in the different frequencies, you get these different answers for the current. And you see that it hits a peak current right here, and it also hits a peak voltage across the capacitor here, which is happens to be the lowest impedance, or very close to the lowest impedance. So it's just kind of an interesting set of graphs showing how the circuit responds under different frequencies.